Now we're going to get into some derivative laws. Those of you who have taken calc before are probably saying, finally, we can do that. So one of the things I want to take a look at are some of the basics. First of all, if you have any kind of horizontal line, so y equals any constant, it could be y equals 2, y equals 10, could be y equals -2, it could be down here. The slope of all horizontal lines are 0. So anytime you have the derivative of a constant, immediately you know the slope is 0. Also, if you have the derivative of just x, nothing in front of it, just x. The derivative of x, what's the slope of x? 1. So the derivative of x is 1. So we're going to use that information, and there's a proof, and you'll be glad to know I'm not going to do it for you, that you can find the derivative of any x to the n by taking n times x to the n minus 1. Genius. So for example, if we have f of x equaling x to the 6th, x to the n, x to the 6th. Well, that will equal n, my n value is 6, times x, and then n minus 1, 6 minus 1 is 5. And guess what? That's it. There's your derivative right there. Pretty simple. Much simpler than doing the limit problem. Don't be mad at me. I have to do it. It's part of the curriculum. Okay, so that is A. Let's look at B. B is y equals x to the 1,000. 1,000 is my n here. So y prime, we can do y prime equals, my n is 1,000, x to the 999. C says y equals t to the 4th. Well, my 4 is my n, so y prime is going to equal 4t to the n minus 1, which is 4 minus 1, which is 3. I have fun teaching this to younger kids because I'm like, hey, you want to do some calculus? Because this is probably the easiest thing that you can teach them. Another notation, DDR of r cubed, that will equal 3r to the n minus 1 squared. And that's it. Lovely, isn't it? Okay, now let's see what else we can learn. Okay, so through a couple proofs, I don't know, before you remember, we talked about you can add functions, you can subtract functions, you can multiply functions, you can divide functions. Well, some of those things you can do with derivatives too. So if you have a string of derivatives, for example, let's look at example 5. This says find d dx of x to the 8 plus 12x to the 5th minus 4x to the 4th plus 10x cubed minus 6x plus 5. Okay, I could take each one of these and write it down and do it like this. Or I could just go across and do the whole thing. So if I start with the first one, that will be 8x to the 7th when you subtract 1 from the 8, plus, now here you're going to multiply. So we have 60x to the 4th. Okay, so we continue on. Then we're going to multiply negative 16x cubed, multiplying and subtracting 1, plus 30x squared minus 6. Now notice when we subtract 1 from this exponent here, this is a 1. When we subtract 1, we get x to the 0 power. X to the 0 power is equal to 1. So this just becomes 6. So that's why when before, matter of fact, let me review this a little bit. When we say if we take the derivative of x, we just get 1. That's because we have 1 times x to the 0 power, which is x to the 0 power is just 1. Okay, so if we have a constant in front of it, then we're just going to be left with that constant. And now if we start with a constant and no variable, that's 0, so it's not even there anymore. Okay, so there's your answer to example 5. Okay, so now the next question is example 6. Y equals x to the 4th minus 6x squared plus 4. And the question is, find the tangent line where the slope, well, it says where the tangent line is horizontal. So we know that if the tangent is horizontal, then the slope is 0. Okay, so find horizontal tangent. In other words, we're looking to find where the slope is 0. Okay, so first thing we have to do is take the derivative, because we know that if we solve for the derivative, we're solving for a rate of change, which represents slope. So we have y prime equals 4x cubed minus 12x. This will be gone because it's a constant. Now that I have this remaining, I want to solve it and set it equal to 0. Why am I setting it equal to 0? Well, because I want to find the slope of the horizontal line, and the horizontal line has a slope of 0. So this represents slope equals 0. So now I'm going to factor out my my 4x. And I have x squared minus 3 equals 0. Now I know that this means that I'm just going to have 4x equals 0, and then x squared minus 3 equals 0. So if I divide both sides by 4, obviously this is x equals 0. Here I'm going to solve. I have x squared equals 3. Take the square root of both sides, and I get plus or minus the square root of 3. Okay? All right. Next, I'm going to start with example 7. Example 7, I have a motion problem, so it's s equals 2t to the 3rd minus 5t squared plus 3t plus 4. S is measured in centimeters, and t is equal to time in seconds. Okay, we want to find the acceleration after 2 seconds. Now, we know that we can find the acceleration of a function after taking the derivative. So first, we have to find the velocity, which is the first derivative. So v of t is 6t squared minus 10t plus 3. That's my velocity function. We looked at that earlier in another section. And now if I take the second derivative one more time, I just do it again, I have 12t minus 10. Now I have 12t minus 10, and I want to find out, the problem says find out what the acceleration is after 2 seconds. I'm going to plug 2 in for my t value, because that's my measure of time. So a of 2, 12 times 2 minus 10. And that will be 14 centimeters per second squared, since it's acceleration. Okay? All right. Now we're going to take a look at a couple exponential functions. How do we find the derivative of an exponential function? First, let's look at e to the x. Remember, e to the x you're going to love e to the x, because the derivative of e to the x is e to the x. Simple as that. Stays the same. Okay? So that's it for e. And let's now move on to looking at some of the other derivative laws. Actually, we'll do one example here for e. Example 8, we have f of x equaling e to the x minus x. So f prime of x would equal, derivative is still e to the x. Derivative of x is just 1. So that's it. Okay, now we're going to take a look at some other formulas, because we don't always have these nice little derivative problems. Sometimes we might have functions multiplied together. Sometimes we might have them divided. So we need to take a look at those formulas. So let's take a look at the product rule first. The product rule says I have one function multiplied by another function. When I do that, I'm going to take the first derivative of one of them. I always do the first one, and then leave the second one alone, and then add to that the derivative of the second one and leave the first one alone. And you might have a little different way of writing it in the book that you have, but I think that is the simplest way to explain it. So we're going to take a look at example 1. I have f of x equaling x to the e to the x. Now you see here the difference is that we are multiplying something by e to the x. So we no longer are just adding or subtracting. So what I have to do is my first part is here, my second part is here. So the derivative of x is just 1. The derivative of e to the x is e to the x. Then or no, we're not going to take derivative, sorry. Derivative of x is 1, then leave it alone. Second part, derivative of e to the x is e to the x, and then I'm going to leave my f of x alone. Now, sometimes we might want to, we call it clean it up a little bit, factor out an e to the x, and that's what we would get. Example 2. F of t equals the square root of t times a plus bt. Well, here we have a whole bunch of variables. All right, so let's take a look at how this would be. I don't know if I'm going to have enough room on this paper, but we'll give it a shot. All right, so now I have t and I have b to the t. So I have two things that I'm multiplying together here. This is the first part, this is the second part. All right, let's find the derivative of the first. Now, we haven't looked at this yet. Let's come over here and examine it. Square root of t is t to the 1/2 power. So t to the 1/2 power, you use the power rule the same. You have 1/2 times t, subtract 1 from 1/2. When I subtract 1 from 1/2, I'm subtracting 2 halves. So I have negative 1/2. Okay? So let's take a look at the derivative of square root of t. We just did it here. 1/2 t to the negative 1/2. And now I'm going to leave this one alone. And then I'm going to add to that the derivative of this. Now, we are going to use a and b as constants. So I was just looking to see if they made that clear. But they didn't. They do on the side. On the side they say a and b are constants. But in the problem, they should have told you right away that a and b are constants. Makes things a little easier. In other words, this could be a 2, this could be a 3, or this could be a 6, this could be a 1. So if I take the derivative of the constant, I get 0. It's gone. And then if I take a derivative times b times t, I'm just going to be left with b. And then I'm going to leave my first one alone. Okay? So now let's take a look if I can simplify that a little bit better. I have 1/2. On the top, I'm going to have a plus bt. Really don't need that 1 there since I just put that on the top. On the bottom, because I have a negative exponent, I'm going to have the square root of t. Plus b square root of t. Now, I'm going to need to, no, you don't have to. I guess sometimes you can combine it depending on what you're asked to do. Let's say we were asked to combine it here, and that means I have to find a common denominator. So I have to multiply this side by 2 square roots of t. When I do that, I will have a plus bt still here. Plus, now when I multiply these together, the square root of t and the square root of t is just t. So I'm going to have plus 2bt. And all of that will be over 2 square roots of t. So simplify it. I have a BT and a BT. So I'm going to go ahead and write that over here since I'm running out of room. I have A plus 3BT all over 2 square root of T. Well, might need to get a new pen now. Okay. All right. Okay. So there's that one. Now, example 3 says, find the product rule, and they're going to give you some information after that. They tell you G of 4 is 2, G prime of 4 is 3, and they want you to find F prime of 4. So, let's take a look. Example 3, f of x equals square root of x times g of x. That's the problem. They're not telling you what g of x is right now. All right. So now they tell us over here that g of 4 is going to equal 2. G prime of 4 will equal 3. And they want you to find f prime of 4. All right, so let's do this. Following our rule for product rule, we can find the derivative of the square root of x. So remember, this is x to the 1/2, so that would be 1/2 x to the negative 1/2. Okay, so f prime of x is 1/2 x times negative 1/2 times, leave g of x alone, plus find g prime of x and leave the first one alone. Okay, so now see if we can simplify that any. Really can, well, I can probably write it a little nicer. Okay, and now they give me the information that I want to find if f prime of 4. So I need to find g of 4 is 2. So I can come down here and put those values in. G of 4 is 2. G prime of 4 is 3. And find this. So, okay. So if we're looking at 2, or I'm sorry, looking at 4. I'm sorry, I don't know, my mind is just like veering off today. Okay, so I'm going to go ahead and plug these in. G of 4 is 2, so I can put 2 over here, over 2 square root of x. G prime of 4 is 3, so I'm going to put a 3 here, square root of x. Finally, since I have this now, I can just substitute 4 in. And square root of 4 is 2, so this is just 2 over 4, which is 1/2. And 3 times 2, which is 6. So my answer is 6.5. Okay, that's the product rule. Now we're going to take a look at the quotient rule. It's a little bit different. And order does matter when you do the quotient rule. Okay, so if we have f of x over g of x And you need to take the derivative with respect to x of this function. Very important. Whatever function is on the bottom, you bring it up first and leave it alone. That's a must. Then you take the derivative of the top, and it's subtracted. Leave the top alone. Take the derivative of the bottom, and then finally, whatever was on the bottom, you're going to square. Okay? So, the biggest thing with this formula is you have to do it in the right order. Whatever g of x is, you're going to bring it up, take the derivative of this, then put this here, and then take the derivative of g of x, all over g of x squared. Now let's look at an example. Y equals x squared plus x minus 2. All of that is over x cubed plus 6. All right, we want to find y prime. Now, this on the bottom is our g of x. This on the top is our f of x. So let's use our formula to find the derivative. I'm going to bring g of x up first. Differentiate the top. Then minus. And differentiate the bottom. Whatever is on the bottom, I'm going to square it. All right, so let's simplify the top. We're going to multiply by foiling this out. And we're going to multiply it out over here. And don't forget to distribute your negative. We might as well do that here. And go ahead and bring down the first one. Now, is there anything we can combine? There is. So I have negative x to the fourth minus 2x to the third plus 6x squared plus 12x plus 6. All of that is over our bottom, and normally when it's like this, we don't multiply it out, we just leave it because we have to see what we're going to do next. Okay, so this would be our y prime. Let's try another example. Example 5. Y equals e to the x over 1 plus x squared Okay, so again, whatever is on the bottom, I have to just bring it up. Then differentiate e to the x, which is just e to the x. It doesn't change, remember. Then subtract e to the x times the derivative of the bottom. So if I differentiate this, I will get 0 plus 2x. Now I can simplify this, multiply this through. And all of that is going to be over 1 plus x squared squared. And we see if we can combine anything. Let's see, we have an e to the x and an x squared, so that doesn't work because that's just a single. So that looks like that is it. Let's try taking e to the x out here first. We might be able to move some things around, because this looks awful close to factorable, and it is once I put it in order. It's a binomial square. So that means it factors x minus 1 quantity squared Okay. So finally, we just want to review all of the derivative laws that we went over in this section. Lesson 11. Again, ignore the fact it says 3.2 here, because right now we're looking at Section 3. And just to review, we want, so I'm going to move this up a little bit so you can see it a little closer. We have the derivative of a constant is 0. We have the power rule here, n times x to the n minus 1. Derivative of e to the x is e to the x. If I have a constant times the derivative and it's to take it to the derivative, I'm going to have that constant times the derivative. This just means that I can go through and differentiate each one and add them together. I can do the same with subtracting. This is my power rule. Or not my power rule, my product rule. So I leave f alone, differentiate g, leave g alone, differentiate f. And then finally my quotient rule, must bring g up first. F prime minus f times g prime, all of that over g squared. And that is it for lesson 11.